Good afternoon. This is Richard Carr, Wildland Fire Research Analyst with Canadian Forest Service, Natural Resources Canada, located in Edmonton, Alberta. So we'll provide the annual 2020 Wildland Fire Seasonal Forecast using our May 1st run. We do this at the beginning of each month. So this will be the May edition that I'm presenting here. As I go through the presentation, I'll just show you where you can find information on our webpage, and that is updated each month. So I'll remind everybody of that partway through the slideshow. All right, brief agenda here. This presentation provides a bit of background information. I'll review forecasts made in April and June last year, just to see how they did. I'm skipping the May forecast from last year since we did have a problem with that we haven't been able to resolve, so we had some funny results. We'll summarize current global and Canadian conditions, conditions that lead into this current fire season. And we'll just briefly go over the methodology for our forecast and see what the 2020 forecast brings. We'll start with the background information. These maps from Environment Climate Change Canada just show how temperature and precipitation patterns have changed over the past 30 years or so. So on the left, we've got the temperature map. Where the orange is darker, it means temperatures have increased annually. So we see the biggest increase, of course, in the north, but also a patch in southern BC that seems to be increasing a bit more rapidly. Maybe not so much change in the southern prairies. On the right, with precipitation, things to note are maybe the drying out where it's orange around James Bay, southern Nova Scotia, and a band from the southern Pacific coast up through central British Columbia and into central Alberta. So part of that area, we've had fairly large fires over the past few years, so that might be something to take note of. Just a brief history of fire in Canada over the past 30 years or so. On the blue histograms gives the area burned for each year. Just off the chart on the left would be 1989, which had the largest area burned that we recorded, which was just a bit over 7 million hectares, if I remember the number correctly. And the black line is the number of fires. You can see things are quite erratic. Now, some of the things that we do see in this erratic pattern are the quiet years with the area burned tend to be not as quiet as they have been historically. We haven't had any of those huge area burned years such as 1989 or 1995 for a while. Over the past 10 years or so, the amount of area burned has been a bit more consistent, and quite often it's running about close to double our annual average. Number of fires appears to be dropping off a bit. Could be various reasons for that. One is the way that fires are reported. For example, I think historically some agencies may have reported an unattended campfire as a wildfire. I don't know if they still do it that way or who does it. Of course, I guess with the amount of effort devoted to things like FireSmart and just bringing fire information to the people through websites and things, urging people to be careful, maybe that has taken an effect, and people are being more careful and starting less human-caused fires. And of course, there's changing climate patterns that may affect the number of fires as well. And just another little reach out into the unknown, I think, is in the large area burned years, maybe there's enough area that's burning that we don't get as many new fire starts in those particular areas. Like if the area is burned substantially, then you can't get new fires going there for some time. All right, so I'm going to jump into some climatological influences here. First is the ENSO forecast, El Nino Southern Oscillation. It is has a big effect in spring in Alberta, at least, maybe in Saskatchewan as well. We've got a chart on the next page that'll talk a little bit more about, so I'll explain that. But the forecast here, the latest forecast from the middle of April, shows most of these models are predicting a neutral pattern over the next few months and into next winter. It means those lines are in between the horizontal red lines. So we have, those are sea surface temperature averages in the El Nino region. So if the lines are above that top horizontal red line, we're in an El Nino. If they're below the bottom, -0.5, then we're in a La Nina. In between, we just consider it neutral conditions. Now, we do note that at this time of year, these forecasts have a tough time predicting trends. The indexes tend to be weakest and quite noisy at this time of the year. So as we get further into summer, the ENSO forecasts become a bit more accurate. Well, those pink lines are just pointing out the Canadian model, CAN-CFS, which you see in the legend there. Now, fire problems in the ENSO events in Alberta, the little yellow boxes there highlight some of the big fire years, 1995, 2001, 2011, 2016. And we note in Alberta that if we either have a strong positive or negative ENSO event, it can create problems. We have the El Nino, the positive ENSO event, we tend to get warm, windy, dry weather. If we have the opposite, if we have a strong La Nina, Central Pacific Ocean temperatures are colder, we tend to get dominated by Arctic air. And usually a bit cooler as we get further into spring, temperature difference is a bit less, but it still brings very dry and quite often windy weather into the province. Now the orange highlighted boxes are some of the years that you see in British Columbia, and they seem to have some of the big fire years when the ENSO indexes are transitioning from positive to negative. So that's happened in about half of those boxes that we've got highlighted. And there's probably other influences at work as well, and we'll talk about those in a few minutes here. Sunspots are at another minimum at this time. There is some evidence that when the sunspots are at the minimum, it tends to weaken the subtropical high pressure areas. And if we weaken those, maybe we won't get quite as much hot, dry weather in Western North America. Pacific decadal oscillation, we just had a slight return to negative conditions over the past year or so. The diagrams at the bottom there show the warm and cool phases of that, and we're actually looking at a spring pattern here. So the warm phase, we've got warm ocean temperatures right along the west coast of North America, and colder water out a little farther west. Cold phase to the right tend to have a bit more cooler water towards the coastal region of North America, and warmer temperatures out to the west. And we're seeing that pattern emerge right now. We'll take a look at the sea surface temperatures in a few minutes here. I think over the past few years, once we swung from negative to positive back in about 2014 or so, we probably saw a little bit of drying out in the southern parts of British Columbia, Alberta, and in the prairies maybe. And we go back into a negative, maybe we'll see a little bit more moisture in those regions again. But I think it's a bit too early in this period to tell. We might swing back to positive, and we'll just have to keep watching and see where it goes. North Atlantic oscillation, which probably has a bigger effect in eastern Canada, but can certainly affect things in the west as well. We've got a recent return to positive conditions. So the diagrams on the right here, and these are actually kind of a winter pattern that we're looking at. In the positive phase, we tend to get Arctic air bottled up a little bit further north, and you might have some outbreaks, but maybe not quite as far south as they'd usually get. Bottom right diagram there gives the negative phase. So when you get those blue and purple colors, you can see that those Arctic air outbreaks carrying on right down to the southeast US. It tends to keep slightly more stable conditions up over the northern Atlantic provinces and maybe northern Quebec and Labrador. All right, we'll just step into the review of 2019. Fire statistics from 2019. Number of fires, we've got several different sources here for area burned and number of fires. They're reasonably close, so I'll just round the numbers off. On the left-hand column there in green, about 4,000 fires. 10-year average to the date that I took these from, early September, is running close to 6,000, so percent normal's around 70%. Area burned is somewhere around 1.8 or 1.9 million hectares, compared to a 10-year average close to 2.8 million. So once again, we're in that 65 to 70% of area burned. So well below normal values for 2019. Of course, it was a very busy spring, and you can see that in the bottom graphs here on the left, the seasonal area burned. The histograms are plots per week, starting in probably early May or so and continuing until situation reports end, probably the end of August or early September. So we've got Alberta fire activity going in the spring. We see the histogram sticking up above that red line, which is that 10-year mean, then tapering off once we got into the summer and remaining pretty much constant. There were some other areas of activity I'll talk about in a few minutes, but Alberta seemed to carry most of the area burned in 2019. Number of fires really didn't reach that red line, stayed pretty much below average all year long. We just look at these numbers by province or territory. On the left, the number of fires by province. Well, Yukon was the only one that seemed to be a little bit above average. Every other province or territory had fewer fires than usual. If you look at the area burned on the bottom right, and you can see that BC with the blue arrow there is just barely showing up on the graph. So a very small area burned compared to normal. Yukon, Alberta, and Ontario each had a bit more area burned. Things that maybe shaped the fire season last year, we had a fading El Nino. Still with the El Nino condition there, it probably contributed to a warm, dry spring, and you quite often get fire conditions with an El Nino. Now, what the media terms the blob, the warm ocean temperatures in the Gulf of Alaska and off the west coast of British Columbia and northwestern states. You can see it's right up against the coast and very little cool water out there. So with warmer water, maybe modifying the atmosphere a bit, allowing a bit more evaporation, and maybe a more consistent storm development may have helped increase rain through British Columbia. So that picture was taken from July 29th. That should say 2019, so we didn't change the year on that. All right, for our predictions, we're looking at the two runs here. Predictions for the months of May, June, and July. The top row is our predictions from the April forecast. So that you can see in May, we were highlighting an area of British Columbia and Alberta, and we certainly had fire activity starting up in that area for sure. June had carried on, so we had some activity up in Yukon, northern Alberta, and northern Manitoba, and those regions specifically, I guess, maybe a couple of false alarms in June there, southern BC for one, and the area on the Ontario-Quebec border. July, once again, we had a false alarm in British Columbia, but maybe did a little bit better in Manitoba. June run, we've got a line diagram here, and we create these with a little bit of just visual assessment of what other models are predicting, as well as what the Canadian climate models do. So the June run, we're still highlighting southern BC and still a false alarm because nothing much happened there. Inside the dashed line in Alberta, northwestern BC, well, activity that started in May, we expected to carry over for probably a month or more, I think, since that area was very dry last spring. And we had a reasonably good placement for the area around the Saskatchewan-Manitoba border for June there. July, we highlighted most of Western Canada, but really we just got spotty areas burning kind of along the northern fringe of that area. And you can see that with the hotspot plots here. On the left, June 30th, well, I had the Alberta fires going for some time, so they had got pretty big. starting to see activity in Alaska and Yukon pop up, and some just east of Lake Winnipeg. By the end of July, maybe a bit more through the Northwest Territories, southeast of Great Slave Lake. Yukon seemed to be fairly steady throughout at least part of July, so the area burned increased up there, and that area east of Lake Winnipeg continued to be fairly active. After that, though, it pretty much tapered off and not much happened. All right, 2020 seasonal prediction. We'll take a look at starting conditions. Now, we actually start this in 2019. We take the fall drought codes. That's the moisture content in the deepest organic layer in the soil. And we apply an overwintering process. We adjust that based on the amount of winter precipitation, and we come out with new drought codes in the spring. So normally, by late summer, early fall, we see most of Western Canada as red. It's pretty normal to have fairly high values there. And one thing that we wanted to look at, though, was northwestern Alberta, since it was quite dry last year. A hint of dryness still carrying on through the winter and into the spring. In southern Manitoba, although it wasn't particularly dry last fall, they didn't have a very substantial snowpack over the winter, so I just wanted to keep our eyes on that area, southeastern Saskatchewan and southern Manitoba. I don't think too much has happened there. There's been a few things, but nothing too major, so it's probably a good thing. As we get towards the Ontario border, they had pretty good moisture going into the winter, so probably not too much concern there early in the spring at least. British Columbia, the deep valleys lose snow pretty early. They've had a pretty dry spring out there right from probably partway through March up until probably currently still. Talk about that in a minute or two as well. All right, on the left from Agriculture and Agri-Food Canada, just looking at the percent of average precipitation for the past 30 days. So you can see a lot of red right across the country from Western Ontario all the way to the Pacific coast. Now, if we looked at, a 60 or 90-day period here, we'd still see a fair amount of orange or red color there, and quite notably, I think, on the coast, it was quite dry through the latter half of March at least, and April, at least part of April, and again in May. And we're seeing Arctic air dominating a lot of the prairies, so, even though it's been a bit cooler, and there is still snow melting in parts of the northern parts of the provinces. It has been quite dry, and we haven't got too much new precipitation there. Top right, Canadian Drought Monitor. This is from the end of April. See a patchy pattern. The drought's not as extensive as it quite often is across the country, but if you compared this to the end of March, well, we'd see a few more patches appearing in the western half of the country, while Labrador area tended to shrink quite a bit. It covered pretty much all of the territory at the end of March, but it shrunk down to a smaller patch by the end of April. Just on the bottom there is a snow cover. Red line gives the mean 2 centimeter depth at this time of year. So you see white above the line, then it's melted earlier than usual. If you see color below that red line, then there's snow still hanging on a bit later than usual. We've had fairly deep cover through a lot of the northern parts of the prairie provinces, Ontario and Quebec, and still struggling to get rid of it up there. It is melting. We're starting to see more holes in the snow cover, and it's getting thinner, so it'll probably disappear in the next week or so. All right, current sea surface temperatures here, and I've alluded to this a little earlier. Inside the boxes are the ENSO regions, and in particular, the red box at 3.4, where the 3 and the 4 overlap, is where the indexes are measured for the ENSO, the El Nino Southern Oscillation. And so just recently, we've had a little patch of cool water emerge and drift westwards across the Pacific. We're starting to see warm water again towards the coast of South America, and it's kind of a mixture of sea surface conditions out there is fairly consistent with a neutral ENSO index. Up to the north of that, in the northern Pacific, while we're seeing that patch of warm water reform, although it is a bit of a distance off the coast, at least so far, and we're seeing a bit of cooler water hanging on right along the coast. So it's probably just an indication that we're into that cool phase of the PDO, at least temporarily here. Okay, I forgot to change the year on that one as well. Take a look at the climate and CMC forecasts here. This is for 2020. I do have a little bullet here about 2019. Well, the two models that CMC run changed in 2019. So the GEM Nemo, and GEM is Global Environmental Multiscale. Nemo is nucleus for European modeling of the ocean. So GEM Nemo replaced the older CAN-CM3, which is the older of their two models. CM4I, just an update of the CM4, just with, I guess, different sea ice and other ocean condition initialization changes. So we've had those two changes in the models last year. I'm still getting used to what they predict, and it can be very interesting, as we'll see in a few minutes. Now, each of these uses a 10-member ensemble, so each model has 10 submodels, each trying to produce a 12-month forecast, just using slightly different physics or initial conditions. And out of those, we use temperature and precipitation inputs. We do have wind coded into our code, but we haven't tested it out yet. And together, those form what is known as CAN-CFS version 2, Canadian Seasonal to Interannual Prediction System. So what the CAN-CFS is forecasting, the latest run anyways, and once again, these come out monthly as well, so they will change. You can find those on Environment and Climate Change Canada's weather pages, just under Analyses and Modeling. On the left is temperature. Good indication throughout the summer here, or at least the early part of the summer, of warm conditions in British Columbia, Southern Prairies, maybe around the Great Lakes and up in the Eastern Arctic. Where the color is white, there's no definite trend, no consensus as to whether it could be warmer or cooler than average. They're showing a bit of a hint of precipitation through the central part of the western provinces over this period. Sometimes, when we're looking at a 3-month period, these things may be biased a little bit by 1 or 2 months, or part of the period, and it won't carry throughout all three. And if we look at June, July, August, and here it's just changing by a month, and you can see the difference in patterns still on the left. Temperature looks fairly high along the west coast and eastern half of the country, pretty much, and up on the Arctic. A little less certainty in the prairies about what's happening. Could go either way. Precipitation, though, we notice that the green areas have shrunk quite a bit, so quite a bit less certainty about rainfall amounts throughout a lot of the country, and just kind of patchy indications here and there, so probably not a good indication of a definite trend. Now, if we go to the US, we can look at all of the North American models put together. Inside the black box in the center are the two Canadian models, the CM4I on the left, GEM Nemo on the right. Here we're just looking at temperatures. The top left there, the NMME, National Multi-Model Ensemble, gives a compilation of results from all of these different models. So I'm taking results from all of those and just creating one map out of them. So we can see a fair amount of predictions of warm temperatures across the continent through June. The Canadian models are in there too, although the CM4I tends to hold a bigger pool of air up in the north. Maybe a little less certainty or closer to normal right along the 60th parallel. If you look at the rainfall patterns here, it's kind of a hint of normal to above normal rainfall in most of the forested zones in the country. Getting a dry looking coastal areas both on the east and the west, so that's kind of interesting. We step into July, temperature The CM4I in the middle on the left within that black box, suggesting a fair amount of warm temperatures across Canada. But here's what we run into when we're looking at two climate models, and sometimes they oppose each other. Nino tends to hold a fairly large pool of cool air across the prairies and northeastern British Columbia. So quite a disparity between those two models. And MME up on the top left, if we kind of combine those, well, we see a hint of warmish weather across a lot of the country, but maybe not too much above normal through the central prairies in central BC. Then if we factor in the precipitation, we're getting quite a mixture here again. CM4I holds a band of heavier rainfall, pretty much southwest to northeast from BC across the prairies up towards Hudson Bay. Nino tends to hold that region drier. A combination of models tends to favor dryness through a lot of Western Canada. As we go into August, most of the models are predicting warm temperature, but once again, the Nino tends to hold a very large pool of cool air across a lot of the country. So it's quite interesting that the one model seems to differ so much from the others. Rainfall, tend to see a lot of the models suggesting a fairly dry month in August. Within the Canadian models, we've got the CM4I that tends to favor the dryness right from Hudson Bay westwards into southern BC. Nino, maybe a similar pattern, but a bit more rainfall through the northern parts of the provinces. Then into September, once again, I think we're starting to see a bit more of a mixture of conditions here. And both Canadian models tend to hold a pool of cooler air across the prairies, and Nino out into the Great Lakes and beyond. And precipitation, once again, we've got quite a difference between the two Canadian models. CM4I has that kind of extreme blob in southwestern British Columbia. So, it's really something to watch. We're several months away from that, but it's one part of the country where fire activity can carry on into the late summer and early fall, given enough heat and dryness. Okay, just going into the actual seasonal prediction here, the May run. And kind of bring up this slide first here, since 2020 is definitely a different year with the COVID-19 pandemic changing a lot of activity, the way things are done, the way people are allowed to do things. Most of the provinces and territories have open burning and recreation restrictions. Not all of them, but I think most of them are following some type of restriction this year, at least to start the year off. It does vary by province or territory. There are, I guess, a few hopes there. First of all is to reduce the human-caused fire numbers, both the amount of starts and area burned. If we can do that, we may limit the amount of smoke in the atmosphere, which of course would help people, first of all, with existing lung conditions or heart conditions that may be susceptible to smoke, but there may be a greater number of them that fall into that category with the COVID-19 pandemic. Also, since agencies can't prepare their teams in the usual way, excuse me for a minute. Oops. Teams have to be prepared in smaller groups, so it's going to take a bit longer to do that. So, if we can delay the fire activity at least through the spring and into the early summer when lightning may take over as a leading cause, well, it can help the teams get ready for the season. We'll still have some human-caused fire. It's industrial activity. We get sparks from trains. Might be other activity, things like welding, or there is some types of industrial field activity too that could lead to some fires as well. Of course, we can't rule out people, conforming to every rule and regulation and common sense. There's going to be a few people out there that may be a bit careless, may do some silly things, or may just have something that gets out of hand. Now, we don't know how this is going to work over the summer. It all depends how the provinces and territories allow activities to restart. So activity may increase over the summer in the wildland areas, and we don't have a good idea of how that's going to happen at all. Of course, the other factor is lightning, which we can't really predict very well. Once we get into late May, the lightning activity tends to increase. It tends to be fairly wet through that period normally, so we don't really get the large numbers of lightning-caused fires in normal conditions until probably July and August. All right, just a little bit of the methodology, and I'm sure that some people that have been watching this over the years are quite familiar with this, but there may be some new people viewing this, so we're going to go over all this background material anyways. So most people are probably familiar with fire danger signs you see down at the bottom of the diagram. If you go out to the forest, you get those little signs that point to low, high, extreme, fire danger, etc. So that's the result of all of these different indexes that work together to come up with the fire weather index, and each province or territory will take that and turn that into a descriptive fire danger category. So highlighted in red, top row on the right is the drought code. So we use that to help initialize our deep moisture models in the spring. Now the FWI, the fire weather index itself, is an exponential relationship. So we linearize that with the severity rating, and we can come up with a daily value or accumulate those into monthly and seasonal amounts. So what we do in our seasonal forecast is use a monthly roll-up of those numbers. Now on the Canadian Wildland Fire Information System webpage, it provides fire weather, behavior, fire locations. There's a link to the interactive map just on the left-hand side under Maps and Reports, and seasonal forecast and information, other information a bit further down, so just within that yellow oval there. There's the URL for the CWFIS at the bottom. All right, so as mentioned before, we use the fall drought codes, apply the overwinter precipitation, try to come out with a new drought code. So that's the diagrams at the top left. For each of those model outputs from the Environment and Climate Change Canada models, we'll calculate our fire weather index and our daily severity rating from those. Now we actually take what we call a hindcast. Models actually forecast for the past 30 years. So we can compare what the models are doing for the current year versus that 30-year period, historical period. So we'll calculate the fire weather index and then the severity rating on each of those model outputs, and we're using about 100 stations across the country. Not a huge number, but enough locations that are fairly well spaced apart and with a good history that we can hopefully get a reasonable comparison. So just on the bottom right there under number 3, do the seasonal predictions. If you take a look at the spread between those purple lines, those are all the forecast elements, and the black line is the normal, the mean value, historical mean, so we can tell if they're predicting above or below that mean. Just for curiosity's sake, that was Edmonton that we're looking at there, and the black dot on the map to the left is where Edmonton is. And then we'll plot that up on a national scale. Number 4, that's the maps that appear on our website. So just looking at a few of the stations across the country, we're not going to go through all of them. The key maps on the right here just give an idea with the green dots where these stations are located. So on the left here, we've got Prince George, British Columbia. We're seeing all of those lines pretty much above that mean. Same with Fort Smith. Prince George tends to be a little moister, I think, through the summer, so normally the severity rating doesn't increase too rapidly. Fort Smith, though, can be quite dry on the other hand, so we see those numbers getting up pretty high fairly fast throughout the year. Going a little further east, L'Orange in central Saskatchewan, still looking all above that normal line, and Thompson as well. Maybe a little bit more closer to the line with the CM4, we see one of those lines coming out just below the normal line. Everything else is above. Most note on these diagrams, we still say CM3 on the top ones, which is actually the gem Nino these days. We just haven't changed the legend text on these plots yet. And a little further east of that, Timmins, Ontario, still looking a bit high there, and we've got a couple of those elements that go sky high, so that's kind of interesting there. Wellbush, Newfoundland, though, it's looking a little bit quieter there, and it's normally quieter through that part of the country. Now, for some of the reports that we do, briefing notes to our Federal Minister of Natural Resources and contributions to the North American Seasonal Assessment Outlook, or Seasonal Forecast Outlook Assessment. I think I forgot the F in there, the NASFAO. We'll take our maps, maybe tweak them a little bit just based on what we're seeing from the North American Multi-Model Ensemble, and come up with line diagrams. Now, from our May run, on the left is what we have on our website. So we're expecting fairly normal conditions in May. Part of that is due to just late snow melt in a lot of the country. We did have fairly deep snowpack and cool spring east of British Columbia, at least. British Columbia tended to warm up fairly nicely, but the rest of the country had either deep snow or cold enough temperatures to really prolong that snow cover and keep melting off at a slow pace. So we just really highlighted, or had the area in southern British Columbia highlighted on our webpage. However, on the line diagram on the right, we also wanted to watch northwestern Alberta and northeastern BC, where it has been dry last year and a bit dryish over the winter as well. Sometimes when you get those very big fires burning in dry conditions, they can go right down to the bottom levels of the organic layer. They can smolder for weeks or months, and sometimes they'll get snow on top of them over the winter, and they still smolder, and then when the snow melts away and the surface dries out, you can get fire coming back up to the surface. We call those holdover fires. So that's an area where that could have potentially occurred. Also, southeastern Saskatchewan, southern Manitoba, just because the snow cover was a bit lacking through the winter, and wasn't extremely dry in the fall, but winter precipitation was maybe a bit substandard there. Now, once we step into June and July, we're seeing a fairly large area in Western Canada that gets highlighted deep red with a potential for a well above average fire potential. Now, we're just basing this on weather conditions, so that's where the weather conditions say that maybe fires can get going more easily here. We're in no way predicting the number of fires nor the area burned. There are separate models being worked on that will do that, but that's not part of our seasonal forecast. On the right, just in June, we've maybe carved out a piece of central Alberta and Saskatchewan, where there's possibly going to be a bit more rainfall than the rest of the region. So we're inside that dashed line. Maybe we'll get an area there that's not quite as volatile. Stepping into July, that red area shrinks a little bit on the left, so a bit more focused on the northern parts of the provinces and the southern parts of the territories. We've really just roughly kept that area the same on the line diagram on the right. August, if you remember back to the North American model plots, well, most of the models were suggesting fairly warm August, and at least some of them are suggesting a fair amount of dry conditions through Western Canada. So we do have that red area enlarging a bit again, just keeping the southern prairies maybe a bit less volatile than the rest of the region. Then when we get into September, well, it's a month where things start to taper off a bit, and especially in the north, we get longer nights, temperatures cool off more. Don't get quite as much heating during the day just because we don't have the long daylight hours anymore. So if you get dew or precipitation overnight, it's probably a little tougher to dry it up the next day. So even though we see a lot of pink up in the North Country in September, it's probably doesn't mean too much at that time of the year. A bit more interesting though is the reds through southern BC and maybe parts of the prairies where you can still get fairly warm and dry and windy weather, and you can get those conditions carrying on into September. Well, you can still carry fire activity through a lot of that region into September or even later. So lots of caveats. There are limits to the climate models. It's tough thing to do to try to predict what weather conditions will be like weeks or months ahead. And even with weather forecasts, it takes a long time to just add another day further out, that's fairly accurate. So with climate models, you might have major improvements every few years. Since these are run every month, you'll see changing predictions with each new run as we get new initial conditions coming in. We do have that spring and so predictability barrier that once we get past, once we're into June or July, that part of the forecast can improve. And of course, when we're just looking at a month as a whole, it can lead to inaccuracy as well. Like weather patterns don't decide just to change at the end or the beginning of a month. They can change partway through. You might get half a month that's cool and wet, and the other half is hot and dry. So you get quite a difference through different parts of the same month. Now we're using just over 100 weather stations to base our normals at, and we can probably increase that number and maybe get a more accurate product that way. Now, snow melt, when we're trying to predict when the snow will melt so we can start our fire weather index calculations, it's just based on historical rates for that location, and we're looking at 30 years of snow depth and how long it took to melt off that amount at each place. So in no way are we looking at the forecast temperature or additional precipitation. Now, conclusions, I guess, for the start of 2020 anyways. It's been a bit slow in most of Canada, although the west has been dry, and we've had some fire activity in British Columbia where it's been warmer and drier. May's been looking pretty normal, and I think it has been so far, except for a few localized areas. Fairly variable conditions across a lot of the country. Although I think in the west it has been tending to be a bit on the dry side. Lots of predictions of heat in the summer. Rainfall, though, is much more difficult to predict, and along with that, lightning. So, those are really big unknowns. Possible improvements. Well, we can include the wind speed in our calculations. You can use more stations, just mentioned that a minute ago, or maybe gridded historical conditions on which to base our normals. We can maybe try to improve our snowmelt forecast process, and some of the climate models will actually help with that, I think, since they can assess the snow cover and also predict when it will melt off. So that's one option we can look at. And we haven't really done a formal validation on this. It's been kind of an ad hoc process so far. So, we hope to really do proper validation each year. And at some point, maybe include the forecast data from other models. And by that, probably the North American multi-model ensemble. And know where to find the data, just haven't spent the time trying to make use of it yet. It's a fairly big learning curve. Now, we did hire a person that was dedicated to taking part of the process and making improvements on it. Unfortunately, he was seconded from another federal department, and when we started working at home due to the COVID-19 pandemic, he decided just to return back to his home department. So once again, we're left, trying to staff that position again. All right, just a few points to remember here. If you look at CIFFC's, that's Canadian Interagency Forest Fire Center, 10-year average, those reports from each province and territory. We have roughly 6,000 fires each year, maybe around 2.7 million hectares burned per year. It doesn't matter if we have a slow year or a very volatile year, we can You can have serious interface fires in any kind of year. You can have serious fires where the seasonal forecast indicates normal or below normal conditions as well. You know, it might depend just on changing daily conditions or conditions that change partway through a month. So we always urge people to check updates for a seasonal forecast in the first week of each month. Once again, in the bottom left there is where you find our seasonal forecast maps on the CWFIS page. As far as monitoring daily conditions, well, I can check the provincial territorial sites. Each one of them have a fire or fire weather web page, so you can look at fire locations, usually fire counts, fire danger conditions, and things like that. Of course, we have all that on the Canadian Wildland Fire Information System as well, and we do our best to bring in daily provincial information to use in our products as well. All right, well, that'll bring the presentation to a close for now. Here's my contact information. Just a slight tweak at the bottom there, since I'm not in the office these days. It's a little harder to reach me through my office phone number, so I've got it temporarily stroked out now. If anybody happens to call that, we do get an audio message through our email, so I'll probably get the contents of that call, but I do have my cell phone number there just for use mainly during COVID-19 or maybe other unusual situations, so can be contacted there if necessary. All right, so not sure how we want to do you know, questions or comments or anything like that, but you could certainly email me. My email address is there. If there's anything really pressing, of course, you can call the cell phone number at the bottom. So we'll bring that to a close for now, and just thank you all for your participation. Bye for now.